Okay, and then if you put that all in your calculator, and I put it in my y equals, oopsie doopsie. So that's second square root. It was 6, oops, geez, having a rough day. Let's just clear it out again. Okay, squared minus 4ac, enter, and it gives us 24. So we get plus or minus 24. 2 times 5 is 10. Now we break that up into x equals negative 6 plus 24 over 10, and x equals negative 6 minus 24 over 10. All right, so x equals negative 6 plus 24 is 18. No, yeah, 18 over 10, which reduces down to 9/5. And then I put, okay, sorry. And then over here, x equals negative 30 over 10, which is negative 3. On your study guide, this is what I was looking at, sorry. You really should keep this as a fraction, but on your study guide, I made this 1.8. So go ahead and make sure that you put that as a fraction, but I won't count it wrong. So 9/5. Those are my solutions. All right, same thing with the quadratic formula. So I need to add p and subtract 3 over. So 2p squared plus p minus 3 equals 0. So we have to use the quadratic formula. So my a is 2, my b is 1, my c is negative 3. So x equals negative b plus or minus the square root of b squared minus 4ac, that's a negative, all over 2a. Okay, so we have x equals negative 1 plus or minus, and we're going to put the square root in our calculator. So go ahead and grab your calculator. Second square root, 1 squared minus 4ac. And I get 5. So plus or minus 5, 2 times 2 is 4. All right, next, negative 1 plus 5 over 4. Negative 1 minus 5 all over 4. So this gives us 4 over 4, which is 1. And then over here, x equals negative 6 divided by 4, which is negative 3/2, or negative 1.5. But remember, keep it as a fraction. I don't know why on the study guide I was doing decimals. Negative 3/2, comma 1. All right, a rocket is launched. So if you see these problems, you immediately draw. I know that I need this point and this point. Those are my most important points. So I can read it and blah, 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 but let's find those first 2 points. Let's find those points first. Okay, clear. The equation is negative 16 x squared, and then it says plus vt. I know that the velocity is a positive 113 because it says with an initial velocity of 113 feet per second. So that's 113. All I did is just plug it in. Jeez. I don't know what I'm doing. Let me just clear everything. Jeez. Okay. Negative 16 x squared plus 113 x, and then it says plus s. That plus s is your starting point. So our starting point was a 105-foot cliff. So plus 105. Go to the graph. Okay, so we find the maximum first by saying second calc max, which is 4. It always starts on my y-intercept, so I push enter. And then I go over until I see our little spider come down. Should be getting close. There he is. Okay, enter, enter. So our maximum is 3.53. You have to round to the nearest hundredth. So 3.53 comma 304.52. Now let's find that 0. So I go second calc 0. I go above and below the 0, which is there. So I need to go below, or I need to go above it. So I'm going to scroll over until I see my little spider above it. There he was. Enter, and now below it. Enter, enter. Round it to the nearest hundredth, and you get 7.89, comma 0. All right, now let's read the questions. How long after the rocket is launched will it hit the ground? Remember, time is always your x. Time is always going to be that first coordinate, or the first value. So how long after the rocket is launched will it hit the ground? Well, here's the ground. It hits the ground at 7.89 seconds. Okay, the next question. What is the greatest height the rocket will launch or will reach? So the height is your y value. So 304.52 feet. And at how long does it take for it to reach its greatest height? Boom, right there. 3.53 seconds. Identify all the intercepts for each function below. All right, honestly, as long as you go ahead and, let's go ahead and subtract 5, you have to have it equal to 0. So 2x squared minus 26x plus 84 equals 0. For me, the easiest way to do this is to plug it in my calculator. So grab your calculator, go to your y, clear it out, and put in your equation. 2x squared minus 26x plus 84. Okay, so our x-intercepts look here. And to me, that looks like 1, 2, 3, 4, 5, 6, and 7. So to check, I go to my table, and I check for 6 and 7, and sure enough, they're both zeros. So since it's an x-intercept, remember those are always coordinates. So 6 is 1, and 7 is 1. The y-intercept is always the constant. So it's 84, and I would write that as 0, 84. Okay, grab your calculator. Let's get rid of all this stuff. Go to y equals, clear it out. 2x squared minus 11x minus 6. Graph it. So I'm not completely for sure. This one definitely looks like it's 6. That one looks like kind of a negative 1/2, but I'm not for sure. So I'm going to check the 6 one first in my table. And 6 works because when x is 6, y is 0. But I can't check decimal, so I have to, let's go back to the graph real quick. I have to do the 0. So I go above it, enter, below it, enter, enter. And sure enough, it tells me negative 0.5, which is negative 1/2. So my first x-intercept is negative 1/2, 0, and my other one was 6, 0. My y-intercept is the constant, so that's 0, negative 6. All right, so this, you have to have your calculator. We're going to go ahead and plug it in. So, oops, stat. Now, if we're going to use the stat button, we need to make sure our stat plot is on. So check that yours is on. Mine was off. Okay, stat, edit, clear out anything you currently have in there. And L1 is our x value. So negative 2, negative 1, 0, 1, 2, 3. Go over to your L2, which are your y values, negative 12, or 12, 21, 16, 6, negative 8, and negative 25. Okay, then we look at the graph. Remember, we are in stat, so we need to make sure that the y equals is out of there. So go back to your graph and you zoom 9. So if I look at this, this is definitely curvature, so that's going to be a quadratic function. So I go ahead and circle quadratic. And then to find the function, I say stat calc quadreg, which is 5. And then now I round all these numbers to the nearest hundredth, which is 2 decimal places, which gives me y equals negative 2.96x squared minus 5.09x plus 15.6. Decimals are okay because you can't turn those into fractions. B. All right, so let's go ahead. You go to stat, edit. I think my x values stayed the same, so I'm just going to keep them in there. My y values definitely did not. Negative 1, 1, 3, 5, 7, 9. Once again, you can zoom 9. And that's definitely linear. It's going straight forward. So that's going to be linear. And you can do lin reg, which we'll do in a second. But look, up here I'm adding 1. Over here I'm adding 2. The slope is y over x. So your slope would be 2 over 1, which is 2. So if it's linear, we know it's y equals mx plus b. So y equals 2x, and then my b is right there, plus 3. Just to check using our calculator, we go to stat over lin reg, and we should get the same thing. So 2x plus 3. And here we go. So in my calculator, I go back to stat, edit. We need to change all of our lists this time. Okay, so I've got negative 4, negative 3, negative 2, negative 1, 0, 1. For my y values, I've got 4, 0, 0, 4, and that should be, you're like, wait, I've seen those numbers. You should be thinking quadratic right now. Let's go ahead and go to the graph, zoom 9. Sure enough, it's got a curve, so that's going to be quadratic. So we go stat, calc, quad reg, which is 5. And there's our coefficients, so we just plug it in as y equals 2x squared plus 10x plus 12. Now, part D says, based on the model in part C, use the function to find the value of y when x equals 3. All we have to do is go back into that equation that we just found and go to y equals. So we plug in 2x squared plus 10x plus 12. And I can just go to my table. And so they wanted to know what y is when x is 3. So x is 3, y is 60. So I would say, all right, well, y is 60. Okay, so each one of these, we're going to take one step at a time. So my A is positive. It's a positive 2, so I know it's going to go up because that's a mini. And then let's go ahead and find its vertex. So our vertex, let's plug it into our calculator. So y equals, wrong page, 2x squared minus 4x. Remember, we're not on stat anymore, so we need to turn our stat plot off. And then we can zoom 6, so zoom standard. Okay, so now we're good to go. So it looks like from here, that's our vertex, right? It looks like it's going to be 1, negative 2-ish. Just to make sure it's smiling, so we know little Miss Minnie is always smiling. We go to the left of the vertex. We go to the right of the vertex. And sure enough, that's going to be, we round to the nearest whole integer, which would be 1, negative 2. So our vertex is 1, negative 2. Our axis of symmetry is an x equals equation. And since our vertex is 1, we know it has to go through that. So x equals 1. The domain for every parabola is x for x, all real numbers. Our range, we say y for all y. And we're going to come back to that because let's graph it really quickly. We need 5 points. Our vertex always goes in the middle, which is 1, negative 2. We go to the table, and we're going to take those values. So second table, we're going to take 2 above and 2 below. So you should get negative 1, 6, 0, 0, 2, 0, 3, 6. And then we can just plot them real quick. Negative 1, 6, 0, 0, 1, negative 2. And remember, they should be lined up together.